My name is Ryan Paul. I'm an engineer on the documentation product team at Stripe. I created Markdoc, the Markdown-based content authoring format that powers Stripe's documentation. I originally joined Stripe in 2016 as a technical writer and later pivoted to my current role in order to improve the documentation authoring experience. Today I'm going to talk about how we created an authoring experience that works at Stripe's scale while balancing the needs of technical writers and engineers. Let's start by talking about the factors that contribute to a great documentation platform. The key elements of a documentation platform are the user experience, the developer experience, and the authoring experience. Let's dig into what that means in practice. A good user experience has documentation that is tailored to the user. For example, at Stripe, we include the user's own API test key in the code samples that appear in our documentation so that the code works out of the box. Another way we customize pages is by conditionally displaying content depending on the user's location or what features they're using. On the front end, you want a rich user interface with application-like interactivity. This means features like tab switchers, collapsible sections, interactive wizards, and more. And finally, you want tight integration between documentation and the product itself. For example, at Stripe, we have a checklist of things the user should consider doing before switching their account into live mode in production. And we can actually detect whether they have done some of those things, like turning on two-factor authentication. And then we can automatically check those off for the user. In the context of a documentation platform, developer experience is all about providing a clear path for our internal developers to improve and customize the documentation. We want engineers on product teams to be able to add new features and innovate without compromising consistency and reliability. And finally, we want to support familiar technologies that align with the existing engineering stack. At Stripe, this means supporting React on the front end so that internal developers can use the company's internal design pattern library. Finally, we get to the authoring experience. This is all about the tools and processes that we provide for creating and editing content and maintaining it through its entire life cycle. When we work on improving our authoring experience, we are aiming for two key outcomes. One is that we want to increase the productivity of our technical writers and make it easier for them to do their best work. Second, we want to reduce friction so that more people throughout the company will participate in contributing to the documentation. Ultimately, the end game here is to make it so that it's easier to submit an improvement to the documentation than it is to file a Jira ticket asking someone else to make the improvement. At a software company, a lot of people talk about user experience and developer experience. These concepts figure so prominently in software industry discourse that they get their own acronyms. Well, we think authoring experience is equally important, so we decided that it should have an acronym too. Building buy-in around caring about authoring experience is really important, and it has a huge impact on the quality and maintainability of documentation. At Stripe, we really try to push the boundaries of what we can achieve in our documentation platform. And what we have found along the way is that this results in a natural tension between the developer experience and the authoring experience. When engineers add ambitious new technical capabilities to the documentation to improve the user-facing experience in novel ways, it tends to make things more complicated for technical writers. To illustrate how this tension forms, I'm going to briefly discuss the architecture of our legacy documentation platform, what we had before we started using Markdoc. Our documentation was literally a giant Ruby application. Each page of documentation was an herb template, which is essentially an application view. This approach gave us a lot of flexibility because we could use arbitrary Ruby logic directly in the page to accomplish whatever we wanted. When we needed new functionality, we simply wrote code in the herb file. But there are a lot of problems with this approach. The large amount of Ruby code interspersed in the content raised technical and security challenges. It was hard to maintain, and it created a high barrier to entry which discouraged documentation contributors. The developer-focused infrastructure that we needed to accommodate the code inside of the content created bottlenecks for documentation content changes. Even trivial content changes had to be subjected to the same code review and CI build system that we use for engineering changes. Code that lives inside of content is simply less testable, harder to debug, and less conducive to static analysis. It also introduces the possibility of runtime errors, which can be difficult to isolate. In an herb template, when someone left out an end keyword to close a block, it would cause the page to throw a 500 error, and we would get a cryptic backtrace that didn't provide much clarity on the actual location of the problem. We would end up having to spend a bunch of time bisecting the page in order to figure it out. We also had a lot of trouble with page-specific logic and style customizations. If you have one-off code with different behaviors on pages throughout the documentation, it's hard to make reliable system-wide changes with any level of confidence that you aren't breaking something somewhere. All of these issues that I'm describing are the result of anti-patterns that can arise if you are using a content system that allows mixing code and content, such as herb or MDX. In theory, you can avoid all of these issues by making good choices and adopting best practices. For example, mutable state, looping, unnecessary programmatic content generation. These are all major sources of complexity and should be limited. Non-trivial page logic should be moved out of the doc and encapsulated, ideally generalized for cleaner reuse so that you don't have one-off code that is specific to a single page. In practice, it's really difficult to maintain that kind of discipline at scale without a lot of gatekeeping in the review process. Engineers and product teams that are working on tight deadlines and want to add custom visual element or a new way of presenting information to their docs will inevitably start adding one-off hacks to specific pages. And once those hacks are in place, other teams will see them and cargo cult them, reproducing them elsewhere in the content. When you have hundreds of people contributing to thousands of pages, you end up with a lot of edge cases and a lot of things that are special cased. That makes it very difficult to ensure that the documentation looks and behaves in a consistent way. So, at scale, expecting people to conform with best practices just isn't enough. You want your documentation platform to enforce best practices by default. So how do you do that? You need your documentation platform to be prescriptive if you want to preserve consistency and maintainability at scale. You put rails in place to give engineers the extensibility they need in a way that eliminates open-ended control over styling and customization. This is a really important point. If you let people use, for example, the CSS style attribute, then you're going to lose control. There is just no way to prevent people from abusing it in ways that compromise quality and consistency in the long run. What you need are strong and discoverable conventions for implementing page logic and custom styling. And you need to make it difficult to achieve those things using anything other than the standardized rails that you provide. This keeps everybody from straying from the happy path. That's a tall order. At Stripe, we've spent a lot of time figuring out how to build a solution that gives us this kind of prescriptive control over extensibility without limiting the creativity of developers who want to innovate inside of our documentation. And that brings us to Markdoc, our authoring platform. So what is Markdoc? It is an extensible content format based on Markdown. We created Markdoc at Stripe to meet the needs of our product documentation platform. It enables an application-like user experience in documentation and pairs it with a low-friction authoring experience that is great for technical writers. We released Markdoc as open source earlier this year, making it available under an MIT license so that others can use and contribute to it. Markdoc extends Markdown with support for custom tags and variables. It decouples code from content and makes it possible to express page logic declaratively. It parses to a data structure that can be programmatically analyzed, which lets us treat our content like data. On the front end, the Markdoc renderer integrates with React so that we can use components to enable interactivity. So why choose Markdown? The network effects are a huge factor. Markdown is familiar to engineers and technical writers, and it's widely supported by a large ecosystem of existing tools. It's also easier to read and reason about than other formats. Markdown is great for writing, but out of the box, it isn't so great for documentation. It's a very flat format that has a very small number of formatting primitives. So it's not great at expressing complex structure or hierarchy, and it doesn't give you a lot of control over presentation. It also doesn't have any templating features like content inclusion or variables. But arguably, the fact that Markdown isn't a templating language is one of its strengths. Simplicity is what makes Markdown such a powerful and compelling choice. Markdown is so successful and ubiquitous because of its intentionally narrow scope. And it is so intuitive and easy to use because it prioritizes readability over feature richness. It's really hard to improve on Markdown without compromising that simplicity and making it less readable. We spent a lot of time thinking through Markdoc's design and the kind of trade-offs that we were willing to make. A lot of our design decisions were motivated by a desire to preserve the ethos of Markdown and protect its simplicity. Markdoc's syntactic extensions to Markdown consist of a small number of new primitives that are highly composable because that allows us to keep the overall surface area small. We want it to be easy to learn so that when a new technical writer jumps into the documentation, they can figure it out right away and not have to make a major time investment in learning new syntax. Markdoc's features include annotations, which apply key value metadata to Markdown blocks, tags, which accept attributes and can optionally enclose other content, and variables, which allow interpolating values inside of the content. Everything else that we need, like content inclusion, conditionals, and custom user interface elements, can be expressed declaratively with Markdoc tags. In order to make the developer experience great, we made it so that defining new custom tags is easy and generally requires very little code. We also take advantage of existing Markdown conventions wherever possible. Here's an example of what Markdoc content looks like. In this example, we have a heading with an ID and an annotation. We have a conditional block that only displays if a variable evaluates to true. And we have a callout with Markdown content nested inside. Markdoc decouples code and content while enforcing proper discipline at the boundaries. Instead of allowing each page to be treated like an open-ended application, it imposes constraints on styling and programming, providing prescriptive rails for content extensibility. The features we decided to leave out of Markdoc in order to protect consistency and maintainability are a critical aspect of its design. For example, when deciding what built-in flow control to include in Markdoc, we deliberately chose not to include looping. We wanted to discourage writers from performing procedural content generation from inside of a document, forcing them to move it outside of the system for better encapsulation. We also decided to leave out variable assignment in order to ensure that the content is fully stateless. The lack of mutable state means that we don't have to worry about the order of execution when a page renders, eliminating a huge class of potential bugs. Although we designed Markdoc to meet our unique requirements and address the challenges that we faced maintaining content at scale, we found that the way Markdoc enforces consistency and maintainability results in an authoring experience with really good ergonomics. We've landed on a format that makes it easy to introduce interactivity without undermining the simplicity and readability of Markdown. And so Markdoc can benefit writers with a wide range of needs and requirements irrespective of scale. Since releasing Markdoc as open source, we've seen adoption in a wide range of different environments, including small solo projects like personal blogs. So how does Markdoc work? It's implemented in JavaScript on top of the Markdown open source library. Markdoc is largely a superset of Markdown with a few tweaks to the standard behavior. We built plugins for Markdown that can handle our custom syntax. We only use Markdown for tokenization. During parsing, Markdoc converts the tokens from the Markdown parser into our own AST format. Markdoc also has its own rendering system, which allows it to support multiple output formats. Out of the box, Markdoc supports rendering to HTML or React, though there are third-party Markdoc renderers for a range of other frameworks. A custom Markdoc tag can be mapped to a React component and passed through its attribute as React props, or a Markdoc tag can have its own rendering function that controls its output. We also provide a way to assign custom React components to standard Markdown document nodes such as headings and paragraphs. Markdoc comes with two distinct React renderers, a renderer that dynamically builds the React virtual DOM tree on the client side, and a static renderer that transpiles the document to JavaScript code. We use the dynamic renderer in our documentation platform at Stripe, but the static renderer is situationally useful in cases where you want to treat a piece of Markdoc content as though it is a React component or a JavaScript module. For example, the static renderer makes it possible to implement a Markdoc loader for Webpack in only 5 lines of code. Although we use Markdoc with React at Stripe, Markdoc content is entirely agnostic with respect to the technology used to present the rendered document. Fully decoupling rendering from the document format gives us the flexibility to present the same content in radically different ways in the future, like incorporating it into a native mobile application or generating a print-ready output format such as a PDF. I even used Markdoc to make this slide deck. I want to briefly demonstrate how custom tags in Markdoc are defined. Custom tags are defined in a schema written in JavaScript that is passed into the Markdoc processor. Each tag defines its attributes, the children that it accepts, and the name of the HTML tag or React component that should be emitted by the renderer. Much of the information you see here in the schema is used by the Markdoc validator to ensure that tags are written correctly. In this example, we only accept specific values for the callout's type attribute. If the writer attempts to use a value that is not accepted or uses an attribute that isn't defined, the validator will block them from publishing the change. Our Visual Studio Code extension uses the schema to highlight validation errors in place so that the user gets instant feedback while they are typing. The validation system is extensible, so we can also implement custom validation rules. This callout tag is defined declaratively, which means that it maps directly to a React component. You can see here that it's defined by the render property. In some cases, we want more programmatic control over the behavior of a custom tag. What you're seeing here is a somewhat contrived example that shows how to define a custom tag that uses a transform function to indicate what it outputs. It will render with one of 2 different React components depending on the value of the attribute called bar. Note the use of the transform attributes and transform children functions. Those will perform the attribute and child processing operations that you get by default from a declarative tag. The transform function can inspect the attribute values and the AST of its children and generate whatever output it wants. The function returns a hierarchy of tag objects that represent the structure of the output. The Markdoc renderer walks that tree of tag objects and converts them to the desired format. Now I'd like to show some examples of how we use Markdoc in the Stripe documentation. This first example is a tab switcher. Each tab is represented by a nested tag. Here you see how we use an inline Markdoc tag to associate a term from our glossary with a word in the doc. When the user hovers their cursor over the word, they see a pop-up with the definition. We've even started using Markdoc to create diagrams that appear in the documentation. We have tags for defining diagram nodes and edges. They get rendered with a React library that provides components for displaying nice-looking interactive flowcharts. So next I want to talk a bit more about Markdoc as an open source project. We develop Markdoc in the open on GitHub, and we publish it to an NPM package that you can add to your own project. At Stripe, we use Markdoc via that same NPM package. So what you see in the public Git repo and what you get in the NPM package is the same code that we use in production to power over 1,000 pages of documentation. You can visit our website at markdoc.io for documentation and other information about the project. We also released a Next.js plugin and template. That's probably the fastest way to get started if you want to get a basic Markdoc site up and running quickly. We also have published a draft of a specification that describes the grammar of the Markdoc tag syntax. The purpose of this draft is to make it easier for other Markdown implementers to build their own support for Markdoc tags. So we think there's a lot of room for individual Markdown implementations to pursue their own approaches for parsing and rendering content and defining custom tags. But we want to ensure that there's the possibility for interoperability at the content level by standardizing the tag's syntax. In the months since releasing Markdoc as open source, the NPM package has grown to roughly 7,000 downloads per week. We've also seen some interesting developments from the community, like projects to create Markdoc renderers for frameworks like Svelte, Vue, and Solid.js. There are also community-driven Markdoc plugins for popular build tools and publishing platforms, including Vite, ESBuild, and 11D. So what's next for Markdoc? We're working on some Markdoc tooling that will further improve the authoring experience. We develop a Markdoc VS Code extension that we use internally at Stripe. It has syntax highlighting, validation, AST inspection, and some other really nice features, but it's tightly coupled with the Stripe authoring workflow. So we're looking at abstracting that out and into the parts that are useful to everyone and creating a Markdoc language service for VS Code and other editors that support the language service protocol. When that's ready, we'll release it as open source. We're also working on a browser-based editing component for Markdoc content that is based on the Monaco framework. This will be suitable for people who want to build content management systems or other browser-based publishing platforms. Finally, we have some really ambitious ideas for building tools that leverage the Markdoc AST for content-aware documentation refactoring. What this amounts to is basically like parsing the document to an AST, performing an AST transform, and then outputting the modified AST back out to a Markdoc text file. We're still at pretty early stages of experimenting with this, but we hope to share some of our tools when we're further along. That brings us to the conclusion of this presentation. While Markdoc is far from being the final word on content authoring, we really hope that our contribution to dialogue will inspire others. And I hope this presentation has provided some useful insight into how Stripe balances development experience and authoring experience at scale.
I feel like that you got a really kind of overwhelming reception in chat. I feel like there was a whole lot of like feeling seen and appreciation and everything. And so I just wanted to say, thank you from everyone kind of in audio form as well for kind of coming forward and giving the talk. And yeah, I think it was really well received, I would say.
Thank you very much. And thank you to everybody in the chat. It's a very difficult subject to talk about sometimes.
Yeah, no, and I think people really appreciated that. And I even saw somebody who was like, I decided to come to the conference just for this talk. So, know that, that impact is there as well, right? People are really appreciating it. And it did seem like it was just a really wonderful kind of almost like manager's guide to understanding your employee kind of thing. And there was a few questions that people had. One of the ones that I was kind of curious about kind of starting with is just kind of like if you found kind of management techniques that work well. I think somebody in particular asked, did sprints help? Did different timeline lengths help? How did that kind of work? Does like more like more close timelines kind of help to give you that, to lessen the distance between the spikes in productivity, or how has your experience been with that?
So it's a really interesting subject, to be honest, and all of the questions that were asked are also really interesting, and I could spend literally probably an hour on every single question. I've been working with this for a long time and have got a lot of experience and a lot of opinions. In terms of the planning, yeah, I mean, I work in a relatively agile team, as is. I mean, it's quite difficult for an IT support team to be agile at times because it's so reactive instead of proactive. But now that I've moved over to sort of content enablement, it's a little more proactive in terms of what we can do.
Sure.
And there's certainly something to be said for working in an agile fashion. The 30 centimeter metaphor that I shared, you can imagine the same thing, but split it down into 5 centimeter chunks, right? And working at 5 centimeter chunks, and all of a sudden the task looks much less daunting, but your deadlines also look much more daunting. But the research time also goes down, and it for me personally, it scales particularly well. But sometimes, I mean, I prefer the shorter form projects because it helps me. The short bursts of focus help me. But sometimes it's not possible. Sometimes you need to rewrite an entire knowledge base with 100 different documents, right?
Definitely. All right. I'm gonna let Ryan in. I just saw them pop up in our chat. Yeah, no, it's really interesting, right? The work does not always scale linearly. Hi, Ryan.
Hello.
All right. Well, since you showed up, I also wanted to kind of ask you a question here. A lot of people had a bunch of interesting conversation during your talk. I feel like the topic of documentation tooling is always an interesting one. And so, yeah, I'm just curious a little bit more to hear how kind of Markdoc works kind of in the standard workflow. I think we had a lot of people asking, like, how does it work in various editors? How does it work with IDEs? Do you have a little bit, is it just kind of like normal Markdown with like comments that the other stuff is kind of interpreted as, or how does that actually kind of work normally?
Yeah, so one of the reasons we wanted to extend Markdown is because there's such a large ecosystem of existing Markdown tooling. We wanted to be able to take advantage of the network effects there. So in a lot of places, it'll just treat the Markdoc tags as though they are part of the text body, but everything else will work as you would expect. So for example, GitHub will render a rich text preview of the Markdown content, and you'll just see the tags and the text content. In Visual Studio Code, we have our own extension at Stripe that we've developed internally for highlighting and validation and a lot of other functionality. We're currently working on abstracting out some of that functionality. We're going to create a VS Code language service that we're going to release as open source at some point. So, I think for the rest of the tooling, I think it's coming.
Awesome. Yeah, no, it seems like that's one of the big benefits of kind of building on existing kind of an ecosystem, right? You're able to kind of build on top of the existing stuff and then maybe just add the syntax for your various pieces into your syntax highlighting. And I'm going to try to kind of alternate questions, though I realize the segues might be a little tricky here. I feel like we have like a pretty deeply technical talk and then a little bit more of a process and kind of mental health talk, really. And so, yeah, I did want to ask as well, back with you, Tyler, like, how does this kind of work in the real world I know people kind of had, how does the strategy work, for example, when taking into account, the fact that we all live in a workplace with constant interruption and all that kind of stuff, like maybe your last 2 days of productivity get interrupted somehow. Have you found kind of issues there, or does it work pretty well in kind of that real world kind of job context, I guess?
For sure. I think one of the big drawbacks to my process is absolutely that, when if I know that my limit is a certain amount of documents per day, or I know how many sort of lines or paragraphs I can write in a day, and I sort of really squeeze that into the minimum amount of time possible, as I'm wont to do, and as so many other people with ADHD have told me that they do too. That capacity for distraction, or not even necessarily distraction, but when something comes up, right? Like, I don't know, maybe the fridge stops working or there's a power cut or something, and all of a sudden you're just not able to work. It definitely has a really big impact there. And it's one of the biggest drawbacks that I find. And I try to be hyper aware of it and give myself as much room as possible, as much sort of maneuverability as possible, whilst also understanding that I have a process and I need to work in my process in order to get my best work out. And it's a fine balancing act, and one that even after 3 years, I'm not close to finding 100% perfection with it.
Well, and I think that's probably the reality for everybody, right? We all have our own productivity like methods that only work part of the time. I think that's, also kind of internalizing that is the case for everybody is super valuable, because there's no, perfectly efficient machine as human. And I guess to segue into that kind of workflow kind of productivity thing, I think a lot of people were really impressed with the Markdoc, all the work that's there, kind of the deep thought that's gone into it. And I think people were just a little more curious about kind of what the team behind that looks like. What's the kind of resources that were kind of required to create such a well thought out tool? Like, what's the team look like, both kind of for Markdoc itself, but then also, I mean, whenever we talk about Stripe Docs, people would ask about Stripe Docs. So just kind of the whole kind of Stripe Doc engineering team as well, people had questions about.
Mm-hmm. Yeah, of course. So Markdoc actually started out as a solo project. I created it myself. The team brought a lot of good ideas to the table when we were working on migrating the content over. Of course, a lot of our custom tags and things like that are efforts from the Docs product engineering team. And then when we were preparing to open source it, 2 members of the team in particular really helped with a lot of the cleanup and refactoring and getting the APIs into a finalized state. As for the Stripe Docs product team, I believe we are 10 engineers. Then we also have an engineering manager. And we are currently looking to hire a product manager, which, so by the way, anybody who's watching, we have a job listing. But yeah, so we've a few of those are recent additions. But yeah, we did basically a complete rewrite of the Docs platform over the past 2 years with this team of 10.
Okay, yeah. So I mean, 2 years with 10 people, that's a pretty solid engineering effort, or that's a pretty substantial team. I think a lot of people, they're given the amount of people that are kind of in the solo writer reality, I imagine that is almost like an unfathomable amount of resource to put towards these projects.
Yeah, it was a big investment by the company. So when I started 6 years ago, there were 3 technical writers and no engineers. And so today, when we've created that team, it was a big swing.
Yeah, and I do think it's one of the things I mentioned in chat as well, right? Is like, if you're gonna, people are like, how do I get Stripe Docs on the cheap or whatever, right? They're like, oh, this is such a great example, and it's like, well, there's a lot of engineering, there's a lot of love that goes into that. I think your talk really covered that, the amount of work that goes into kind of the system and the history. I think somebody commented like, you're basically like, you end up building a whole CMS, right? You're kind of like, we're going to build a doc platform, and then it slowly kind of scales up. And I love that you all kind of stepped back and were like, let's think about this a little bit more. Let's rethink how we're approaching this in a way that, can both enable open source contribution, but then also, and allow us to have a little bit more foundation for our engineering. And maybe, the engineering time doesn't quite take as much in an ongoing fashion because we're architecting it properly. So I was curious, Tyler, this is a little outside of the scope, but you did mention kind of working at GitHub. So to kind of connect those dots, I was curious just to hear a little more about kind of how GitHub does documentation. I'm sorry if that's kind of outside of the scope of the talk, but I was just curious, I think that's another name that people look at and are really just curious what the workflow looks like. Would you be able to tell us a little more about kind of what your process looks like?
Yeah, so unfortunately, I can't really speak for like the docs.github.com team or the docs team at GitHub.
Okay, sure.
I write documents for the internal IT team. So I started with GitHub on the internal IT team as essentially just an employee IT support agent. And a lot of our knowledge was tribal knowledge within the team. And then over a relatively short period of time, all of the tribal knowledge disappeared, and the longest serving member on our team have been there for 18 months, and our documents were a little behind in terms of the internal and the IT to rest of company documentation. So a lot of those processes got lost, and we had to rebuild them from the ground up. And my job really came about because of that, and because of the need to preserve that knowledge for the future. So yeah, my entire job essentially was, I was given a knowledge base that had been written over a period of about 5 to 6 years that didn't encompass all of the processes. It was written by 7 or 8 different contributors with 7 or 8 different ideas on structure and how content should be arranged and written, and 7 different voices really. And the biggest thing for me was I had to take a step back and look at the whole thing sort of as a holistic, or to take a more holistic approach, and sort of take one level of abstraction upwards from this document needs updating, right? It's not just this document, it was the entire base.
Right, what's our process?
For sure. Yeah. So I ended up for probably my first 6 months, I wrote very few documents because my entire time was focused solely on content strategy, creating a voice, creating templates and things like that. And creating a scalable structure for the future, right? And making sure that it was something that I could teach other people. So when my job is no longer around, I've said it before, as an IT support person, first and foremost, is where I spent 10 years of my career. A tech writer shouldn't really be needed for an internal IT team specifically, just for that team. Maybe as a wider function, as part of a wider function, right? But a full-time IT tech writer is a little over the top sometimes. And my entire aim is to make myself redundant, right? Build up an entire foundation of a knowledge base that can then be maintained in an easy fashion, and other people can be taught the way that it works very easily, without me having to be that sort of single point of contact, single point of failure for those documents.
I feel like that story is as old as documentation, right? It's like, oh yeah, we don't write stuff down. People just know things. Then it's like, oh wait, everybody who do stuff is slowly quitting. Like, what do we do?
Absolutely.
That's really interesting, and yeah, I think that's a very classic story for a lot of people here, right? They're just really trying to solve their own problems, right? And kind of you end up in that. I think a lot of engineers end up in the role of building tooling because they want to solve their own problem, right? And I'm guessing that's how Markdoc was, right? You're like, oh, these other tools are fine, but like I see a better way to do this. So I do think we're getting a little bit close to the end of our time. So I did want to go back to Markdoc a little bit, which I think a lot of people had a bunch of kind of technical questions that I do think, if you go to the website and browse around, there's a bunch more information there. But I think people did have a question about kind of what that integration, like you mentioned, there's kind of an AST, there's multiple output formats, and there's like integration with React, all these kind of things. I think people are just curious a little bit more about kind of what the vision for that is. Like, how does it work exactly? Is it a static site with user side JS? Does it output a React app? Or, I think people were just like, there's a lot there. So just maybe unpacking that a little bit more.
Yeah. So I think there's also like people want to know, like, is it an end-to-end solution or whatnot? And it really isn't. Like, we built it as a component that you can drop into your site, so it does not handle routing or any of that. It doesn't act as a complete static site generator. What you get with what we've open sourced is the parser, the renderer, and the validator, and then you can kind of integrate that with whatever the rest of your stack is. And so there are third-party plugins, like we have a Next.js plugin that we've released to, and a boilerplate for it. So there are ways to get closer to a complete stack. As for the React integration, there are 2 different React renderers. One of them will output JavaScript code, so it kind of works like you're transpiling your document to JavaScript. And that's what we call our static renderer, is useful if you wanted to do like a static site kind of approach, or if you wanted to be able to build a Webpack plugin that can import a Markdoc document as though it is a JavaScript module. Then there's the dynamic renderer, which it produces a JSON structure that can be converted into a React VDOM on the client side. And so that's what we use at Stripe. so we've kind of built the system around that. We use server-side React rendering with that approach.
So is that like a JSON representation of the AST that's then getting actually rendered via the front end, or I guess then rendered on the server into HTML and then sent to the browser?
Right, exactly. And so we actually have kind of two separate data structures. There's the document AST, and then we have what we call the render tree, which is the kind of the AST that you get after you've processed all of the document nodes. And it is like a JSON representation. It's very close to like what the VDOM would look like. And so we have a very thin client part that just converts it to a React VDOM on the client.
Wow. So the AST is a little bit more kind of, there's like I've done a lot of this stuff in the Sphinx ecosystem, but right, there's kind of like the AST before you resolve references and do all that kind of, it's like here's the input and what it's representing, and then it's like, okay, well, this reference is now resolved, so now we have a representation of that in the output that we can just render, and we don't have to have that resolution logic or whatever on the client side.
Right, exactly. And I think too, because we want to have the AST be rich enough that we can convert it back out into plain text representation, like the original Markdoc source. It needs to have a lot of information in it. And also for validation debugging, we need to know like source mapping and things like that. And of course, you don't need any of that on the client. So the render tree is much thinner. Right.
Yeah. It's like we don't care about, there's no error messages on the client, hopefully, right?
Yeah.
Awesome. Well, I think, unfortunately, that's all the time we have. I do think a lot of people were engaged really deeply with both of these talks, kind of both at a personal and a technical level. I think a lot of people are excited about just kind of the representation and just learning more about all the stuff that's going on in our documentation ecosystem. So we really appreciate both of you presenting and being here for the Q&A. And I do think there's a few extra questions here that didn't get answered in the chat. So definitely if you have a few more minutes to kind of drop some questions there. But otherwise, I guess I'm going to close the conference. So thank you all again for presenting. Thanks everybody for coming. And we will see you all again here in the future in Australia, Portland, or in Europe.